agriculture lies at the heart of all the great civilizations of the world. Only intensive agriculture produces enough food to sustain large settled populations.
The largest diversity of organisms in the known universe, the soil organisms. There's 50 million genus of bacteria and 50 million genus of fungi. And you're feeding the organisms, and their exudates and their interactions are feeding the plants. That's how it works with natural systems, and that's how it works with organics.
Even after a long tradition of organic farming, there are still hundreds of different approaches to it. A big issue is giving back the nutrients to the soil and to keep the helpful microorganisms alive, to secure a rich harvest, not just over years, but permanently, because this is the only sustainable way of agriculture.
Nowhere in nature where man has not been do you ever see exposed dirt. That only happens when man comes and takes the cover. Everywhere in nature where man has not been, it's either covered with needles and leaves or grasses, but the ground is covered. And the reason is because the ground is a living organism.
In the not-so-distant past, the largest part of the world's drylands were wooded. Southern Spain was one big forest, the African Sahel densely wooded. The bare, dry Pyrenees in Italy had thickly wooded slopes. And the Lus Plateau in China was covered with a mixed forest. Jordan, at the crossroads of Western and Eastern culture, had forested hills and valleys. Returning indigenous and endemic vegetation to degraded landscapes helps nature to regulate the hydrological cycle, sequesters large amounts of carbon, increases fertility in the soil and productivity in agriculture, strengthening the resilience of the land and reducing the risk from extreme weather.
They took the trees off, they plowed up the land, started planting crops, and life was good. Fabulous yields for their times. These were all virgin soils, basically, never been farmed, and things went quite well for a while. However, it didn't take but a couple of decades, and things started going south. We had big windstorms, we had wind erosion happening everywhere. Of course, everybody's aware of the Great Plains. This is Garden City in 1932.
You take the pace of modern soil loss and project it out into the future. At that rate, it would only take 150 years to completely denude the world's agricultural lands of topsoil.
So something happened to our soils that caused us not to be able to farm anymore. But what happens? When you do tillage, you do a couple things on the soil. You get a soil that has primarily bacteria. So you flip that soil over with a moldboard plow. Organic matter that's in there gets exposed to oxygen. It burns off, the organic matter content goes down, and you get a soil that has primarily bacteria in there. They're fast burning, the organic matter goes away, you put fertilizer on there, the fertilizer is immediately available to the crop. But these bacteria are not very good in holding our soil particles together.
But the plow have actually been the culprit that followed the axe and caused the kind of wholesale regional soil erosion that actually has affected ancient societies.
There's this movement through the country where people are realizing, you know what? If we farm nature's way, we start saving in inputs. Does nature disrupt itself? It doesn't do that. And if you can learn the principles, I call them the keys to the soil health, is limit disturbance, cover the soil all the time with diversity, 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 have a live root growing all the time. That's what nature does.
Actually gone to that, but how come his neighbor is having this other stuff? And that's what the whole point is here. We're not farming Grandpa's farm anymore. When we took out the forest, we had a certain soil that had 4 to 5% organic matter, and we have been plowing those soils because that's the technology we had at the time, and we've degraded those soils dramatically by taking the organic matter down. And that is the big thing we've done. So you end up with soils that seal easier, and sealing is the process where raindrops hit the soil and then put a crust on top of them. You get more runoff because of that, and you get more compaction. Well, the sad thing about tillage is, by tillage you get more compaction, so you do more tillage, so you get more compaction, and now you're in this vicious cycle. The raindrops splash those soils around, they make seals on the soil. When they dry out, we call them a crust, and sometimes those crusts are so hard that our emerging crops cannot get through them. And actually sandy soils do this a lot worse than clay soils. So you get these soils where the little seedlings can't come through. If we would have had some protection on there, either in the form of a cover crop or residue out there, that wouldn't happen.
And we've seen evidence of that as we've looked at the historic loss of soil carbon. So as we're looking at when we started applying tillage to the soil system, we rapidly reduced the amount of carbon that was in the soil.
All those little branches you see are those mycorrhizae that actually grow into the corn root. And the corn root will then get water and nutrients from the mycorrhizae in exchange for sugars. So it's a beneficial relationship to both the root and to the mycorrhizae. So you dramatically increase the area where you can get to nutrients and where you can get to water. This is one of the reasons that in a year like 2012, when it was really dry, no-till crops were standing up a lot longer in the drought than tilled crops, because they had that bigger area that they could get to water. If you do less disturbance, you get a major increase in earthworms out there. And it might take a couple of years for that to happen. They can help us improve the water quality by infiltrating water in there, but where it infiltrates, it's in those tunnels that have these organic sites that the earthworms have created. So most of our soils are not the great soils that Grandpa and Great-Grandpa had anymore. They're degraded. That gives us issues with crops. Now, wait a minute, Dutch guy. That can't be. I have yields that are about twice what Grandpa had, and things are much better on the farm than they used to be in the 30s. Yeah, we have introduced an enormous amount of technology. The genetics we have in our current crops is very different. Top yields, wheat yields, in the Great Plains used to be 10 bushel to the acre when the dust storms hit. Those guys can pull up to 90 bushels off right now. Much better genetics. We have put inputs in there, fertilizers, herbicides. We're much better at controlling weeds. So we've done all sorts of things to make our crops good. But in the process, our soils have gotten worse than they used to be.
And again, in our modern agricultural systems, what we've done is we've given the plant a lot of nutrients very early in the growing season, which puts a lot of nutrients in that rhizosphere environment. So the plants don't need to have the relationship with the fungi at this time. And so they'll basically not give carbon to the fungi, and eventually the fungi will start to die off, and they'll kind of give up on being able to get carbon from the plant. And that's what's reducing the numbers of these fungi in the system, in addition with the levels of disturbance and the amount of plant growth that we have.
We can use brassicaceae like the turnips and the radishes. We'll show you some pictures of that. Then legumes like clovers and peas we can put between corn and beans. And mixes of those. We find that actually if you start mixing that stuff together, they do better than if you do just one or the other. So the decaying roots add organic matter, because we need to add organic matter to all our soils, because we're low in organic matter after that many years of tilling.
The reason that we have a lot of diseases in our modern agricultural system is because we're growing primarily one type of plant that is supporting the life of very particular types of organisms in the soil. And those numbers of organisms, because they're the only ones getting fed, their population grows out of control. But if you maintain the diversity of the system, those different organisms are going to make sure that one population doesn't grow out of control. So it's very important to have these organisms, and by consuming the bacteria, they can consume the bacteria in very large numbers. And so it's very easy for them to release some nitrogen from the system, because the nitrogen, again, that's locked up in the body of the bacteria is consumed by the nematodes, and some of that nitrogen comes out of the nematode as waste. And then that nitrogen, when it comes out of the nematode, is in a plant-available form because it's been broken down. So it's in a inorganic form instead of the organic form that it was in when it was a part of the body. And when it's in that inorganic form, it now can be taken up by the plant. So it's a way of cycling nitrogen through the system. It goes from an inorganic form into the bodies of the bacteria, and then the bacteria are consumed, and it's released from the bacteria into an inorganic form. And that can go back up to the plant and be converted into an organic form again and keep on going through the cycle.
So it's pretty amazing. Again, same thing. On the right is vegetable acres that really get a tilt a bunch of times a year, rototilt and that kind of stuff. On the left is a guy that had pasture rotation, all that kind of stuff. So the main reason that happens, again, when you till the soil, it's mainly bacteria that don't hold the soil together very well. If you don't do that much tillage, you have more fungi, more earthworms, and the soils are held together much, much better.
I'm in Bavianskloof, or the Valley of the Baboons. This is near Port Elizabeth in South Africa. It's a reserve, which is a World Heritage Site, and it's got 3 biodiversity hotspots. And here, clear, beautiful streams are flowing out of the hills. And this water is flowing out of the hills because it's been captured and infiltrated and retained by the natural vegetation here on the hillsides. But just outside the reserve, there are vast areas where for 3 generations farmers have been removing the natural vegetation. And in those areas, you see severely degraded lands, which are massively affected by drought. Living soils like this retain on average 3 times more carbon than the foliage above the ground. If we were to restore the vast areas of the planet where we humans have degraded the soils, just think what an impact we would have in taking carbon out of the atmosphere. As much as 1/4 of the world's land mass has been degraded, and much could be rehabilitated.
With the scientific input here, we've learned a lot. That areas which are really degraded can still be restored.
The source of wealth is the functional ecosystems. The products and services that we derive from those are derivatives. It's impossible for the derivatives to be more valuable than the source. And yet, in our economy now, as it stands, the products and services have monetary values. But the source, the functional ecosystems, are zero. So this cannot be true. It's false. So we've created a global institution of economic institutions, an economic theory, based on a flaw in logic. We need to consider why it is that the ruins of once great civilizations are found in drylands, and realize that unless we learn the lessons of history, we are destined to repeat them.
But if you ask the economist, in that equation, where do you put the ozone layer? Where do you put the deep underground aquifers of fossil water? Where do you put topsoil or biodiversity? Their answer is, oh, those are externalities. Well, then you might as well be on Mars. That economy is not based in anything like the real world. It's life, the web of life that filters water in the hydrologic cycle. It's microorganisms in the soil that create the soil that we can grow our food in. Nature performs all kinds of services. Insects fertilize all of the flowering plants. These services are vital to the health of the planet. Economists call these externalities. That's nuts.
Tilling, the use of fertilizer and crop sprays are all part of achieving an industrial factory farming system. This does not make sense in economic or energy terms. Factory farming invests 5 joules of energy for every joule harvested. In fact, the food garden is 2,500 times more energy efficient than the farmers with their tractors.
You can't have the soil biology without the plants, and the plants need the microbes. Our job, landowners, is to manage that habitat right here, that pore space.
A chemical reaction which happens and converts sunlight energy into chemical energy, which is sugars, it's carbohydrates. Those carbohydrates then get pumped into the plant and all down through the plant, and the plants are able to make up to 100,000 different compounds from that process. In this process, what actually happens is the carbon that actually goes down through the plant into the roots is actually feeding microbes in the soil. Those microbes in the soil are then feeding the plant. They bring back the nutrients to the plant.
We've cut our fertilizer by 90% and our herbicide use by 75%. And we have not reached a plateau yet. I don't believe that anyone knows where the plateau is. And we think that we're just going to keep pushing the system forward and see where it takes us from here.
Our first year that we did the cover crops, we saw a small yield increase. Typical corn yields were 120 to 150 bushel corn. That year we were seeing where we had the cover crops 170, 180 bushel corn in comparison to where we had the 150 right beside it.
Our average yield in Burleigh County on corn over the last 5 years is 100 bushels per acre. So if we looked at the west side, we had a yield of 122 bushels of corn on the west side. It had no commercial fertilizer, no compost tea, no compost, but it was planted into last year's full season cover crop.
The last 7 years we've reduced our fertilizer costs by as much as 75%, and I'm really hoping that in the next 2 years I can learn to reduce it to zero.
It's a very old story. Tree cutting, unsustainable agriculture, and free ranging of goats and sheep, compounded by new mechanized ways to speed the destruction. Where we have reduced biodiversity, reduced biomass, and interrupted the accumulation of organic matter, we have also altered the ability of nature to naturally regulate the hydrological cycle, the weather, and the climate.
If we don't actually start to repair the ecosystems so that our productivity is premised on a system that runs on natural function, then we have no idea of the consequence. We have no idea of the scale. It's quite terrifying, actually.
200 years ago, there was 8 to 12 feet of beautiful topsoil. I mean, gorgeous stuff. And if you've ever flown across the Midwest, you look down at the ground, it's almost scary. It's just parched, cracked, hard, totally desolate, almost looks like desert. There's 8 inches of topsoil today because it's all blown and washed away, and they're still cultivating. This is not working, and we're losing topsoil. And topsoil in nature, it takes 100 years to build an inch of topsoil. I mean, it is criminal and incredibly devastating what we've done to the planet.
There is proof that large-scale restoration works. The Chinese in the Loess Plateau banned tree cutting and free ranging of goats and sheep, terraced the land and planted millions of trees. The principles of restoration are the same, regardless of the scale. This has to be adopted by everyone.
There is only one option. I repeat to you, only one option left to climatologists and scientists, and that is to do the unthinkable and to use livestock, bunched and moving, as a proxy for former herds and predators and mimic nature. There is no other alternative left to mankind. Let's look at some results. This is land close to land that we manage in Zimbabwe. It has just come through 4 months of very good rains it got that year, and it's going into the long dry season. But as you can see, all of that rain, almost all of it, has evaporated from the soil surface. Their river is dry despite the rain just having ended, okay, and we have 150,000 people on almost permanent food aid. Now let's go to our land nearby on the same day with the same rainfall, and look at that. Our river is flowing and healthy and clean. It's Fine. The production of grass, shrubs, trees, wildlife, everything is now more productive, and we have virtually no fear of dry years. And we did that by increasing the cattle and goats 400%, planning the grazing to mimic nature and integrate them with all the elephants, buffalo, giraffe, and other animals that we have. But before we began, our land looked like that.
A country like Kenya, for example, could almost double its above and below ground biomass through active restoration.
Wealth is being happy, living in nature, listening to the birds, breathing clean air, not having chemical pollution throughout everything, not having these horrible problems. So, you know, we need to redefine and revalue our belief systems. We need to understand that money is a belief system. There's nothing wrong with money, it turns out. The problem is that what is money based on? If money is based on functional ecosystems, then the future will be beautiful. If money continues to be based on production and consumption of goods and services, we'll turn everything into a desert. What is the future for our children and our children's children and generations to come in the future?
The practical solution is incredibly simple. Cover the soil with plant diversity. Get roots into the soil. Use the cover to feed the microbes. The more biomass you have in and on the soil, the greater your harvest. A 30% increase in the first year, a 300% increase over 3 years, and even 500% harvest increases are figures coming through. The answer: think differently, mimic nature.